In this video, I'm going to do this basis proof. So I have a set of n vectors that's a basis for a vector space V, and I want to show that this new set S prime is a basis for V. A basis should both be linearly independent and it should span V. But in this case, because I know that the dimension of V is n, if I have another set with n vectors that's a subset of V, I just need to show that it's linearly independent or that it spans. So I start off by assuming my hypothesis. So I assume that S is a basis for V, and I know then that the dimension of V is n. And since S prime contains n vectors, right? It has n vectors because I've just replaced v1 with this vector and v2 with that vector. So since it has n vectors, we need only prove that S prime is linearly independent. We could prove spanning, but independence is easier. Then, as always, to prove linear independence, we assume that C1 times the first vector plus C2 times the second vector plus C3 times the third, etc., is equal to the 0 vector. And we want to prove that C1, C2, C3 up to Cn are all 0. So let's expand this. So I've gone ahead and I've expanded that. So I have my coefficient on V1 is 2C1. My coefficient on V2 is minus C1 plus 2C2. And on V3, it's minus C2 plus C3. And the rest are all C4 up to Cn, and that's equal to 0. But I know that S is a basis for V. And what that tells me is that this set is linearly independent. So when I have a linear combination like this equal to the 0 vector, I know that each of the coefficients has to be 0. So I've gone ahead and written that down. So I have 2C1 is 0, minus C1 plus 2C2 is 0, minus C2 plus C3 is 0, etc. But if 2C1 is 0, then clearly C1 is 0. And if minus C1 plus 2C2 is 0, then 2C2 is C1, so, and C1 is 0, so C2 is 0. And I can rewrite this to get C3 is C2, so C3 is 0. And the others are all 0 as well. But that's what we needed for the set S prime to be linearly independent, right? We needed these coefficients to be 0, and indeed they are. So that tells me that S prime is linearly independent and therefore forms a basis for V. So I wrote out my closing statement. S prime is linearly independent, and so it is a basis for V.